One of the use cases that we're going after with the Air Force right now is munitions handling units. So these are the devices that load up planes with munitions. And we built for the Air Force a prototype of a robotic arm that would do that. And in fact, the arm was so strong that it got into the Guinness Book as the world's strongest robotic arm. You can find our record if you go to the Guinness Book website. And so that's one application where it's actually picking up a munition, manipulating it, and then able to help assist humans that are actually doing the work. But it's taking the machine is doing the brunt of the automation. So that's one application.
Welcome to season 2 of the Complete AI Guide, your commute-friendly podcast brought to you by georgiabmatthew.com. We are now on Apple Podcast, Amazon Music, and wherever you get your podcast. Like, follow, share, and subscribe so you don't miss an episode. I'm George Matthew, and today we have Hiten Sonpal. Hiten is the CEO of Rise Robotics, leading an MIT-affiliated team that's actually getting smart robotics into production at scale in heavy industry. He shepherded more than 9.3 million in revenues, with validated tech secured 5 million plus in U.S. Air Force contracts. So welcome, Hiten.
Well, that was an incredible introduction. We have an incredible team that made it all happen, and this has been a very exciting company to join as CEO.
Most people think AI innovation happens in software, consumer tech. Why did you focus on heavy machinery, and what problems were hiding there?
Yeah, so this team was founded by 4 co-founders, 3 of whom went to MIT, and they had the vision to build a exosuit. So they wanted to think like an Iron Man suit, but without the jetpack.
Yep.
They wanted to make it possible for humans to be able to jump higher, lift heavier weights, push heavier things. And they saw applications in warehouses, with the elderly, in military, with the defense. And so that's what they were focused on. But during that journey, they had to invent something better than hydraulics to build these systems. And we built our core technology now that we call beldraulics. That doesn't have any fluids in it. It's 3 times as fast as hydraulic systems, 3 times as efficient, 3 times as durable. And so that's the system we went with. And that system, rather than building a market for exosuits, the company decided to tackle the existing market for hydraulic systems. And because our systems are electrical instead of being fluid driven, they have position feedback, they have health monitoring, they have force feedback, all out of the box, which makes them perfect candidates for building autonomous systems.
And I know from my previous role in running an AI startup for troubleshooting of airplanes that we've had, robots would have been ideal, especially when you look at changing of, tires, and the way tires are inflated itself is a hazard to humans. Do you see those kind of applications already in play, or what are the typical use cases that you go after?
Yeah, so one of the use cases that we're going after with the Air Force right now is munitions handling units. So these are the devices that load up planes with munitions. And we built for the Air Force a prototype of a robotic arm that would do that. And in fact, the arm was so strong that it got into the Guinness Book as the world's strongest robotic arm. You can find our record if you go to the Guinness Book website. And so that's one application where it's actually picking up a munition, manipulating it, and then able to help assist humans that are actually doing the work. But it's taking the machine is doing the brunt of the automation. So that's one application. But we can see many applications in and around airfields and in and around any area where the military is doing any sort of staging. Because there's heavy equipment that needs to be pulled, pushed, lifted, lowered, and that's where we see our technology shining.
And so how does replacing hydraulic systems with electric and software-driven systems change how machines operate day to day? What is the before and after scenario? I know there's a lot of hydraulic-based robotic systems in play already.
Yeah, so let's take an example of an excavator that's being run with a hydraulic system, right? When you think about how that system operates, there's an operator that's sitting in the excavator that's closing the loop with their own eyes, right? So they're looking at the bucket at the end of the boom arm and they're seeing how much weight is on the bucket. If they're lifting too much, they can feel the machine tipping over, right? And they get the feel of the machine because the hydraulic systems that they're operating just is open and close a valve, right? It's applying a certain amount of force, but the interaction with the environment is all done through a human making those decisions. So a system like that, for example, can't be teleoperated easily because you lose the feel of the machine, right? Unless you instrument the machine very heavily. Well, if you use one of our beldraulic cylinders instead of hydraulic cylinders, then out of the box, you get the orientation of each actuator, you get the force on each actuator, and you can very quickly build up a digital twin. That digital twin would allow the system to be teleoperated, which is the first step before you can build autonomy. Because if you've read a lot about autonomous systems, they have this long tail of problems that they can't solve. So even warehouses that are using automated forklifts today have a back office with a lot of drivers that step in when the computer can't figure out how to get out of a particular spot or how to pick up a particular piece of good, or there's some issue in the instrumentation that's happening in the warehouse. And so what we make happen is that because you now have teleoperation, you can start building autonomous capabilities on top of it, and it allows you to be able to step in anytime the autonomous system can't handle a particular situation. One example would be that innately an autonomous system would not know if you used a hydraulic system and lifted something too heavy and then tried to turn the arm. It would cause the system to tip over. Well, that's a safety issue. And so rather than try to train a machine learning network to understand all of that, we can tell you just by using the data that, hey, if you turn it left 3 more degrees, you're going to tip the machine over. So you can't do that anymore. So we can put in the safety aspects of the system built from calculation as opposed to built from inference.
All right. So I was just curious to also know, where does AI actually show up in your products today, and where do people often misunderstand its role?
Yeah, so our core offering enables heavy machinery that is capable of AI. Without our systems, it's actually very challenging to build a heavy machine that's AI operated, simply because you have to instrument the system in so many places, and that instrumentation is on the outside. It's not robust, it's very expensive. We give you all of that out of the box, inside the cylinder, sealed and ready to go.
Right. And so I'm thinking that you've also embedded sense and response systems and capabilities into the mechanical components of your solution.
Absolutely. And part of that is, some of it is almost free. So every time you take a motor and you turn it into any kind of force, the force or the torque output of a motor is proportional to the current that's being put into the motor. So if you need more torque or more force, the amount of current you need to put in the motor goes up. And just by measuring the current that you're putting into a motor, which you would do anyway to make sure it isn't overheating, you now know how much force you're applying. So it's almost free. You don't have to do much more to get the force out. And then motors typically have encoders to control the speed. So once you have an encoder, not only can you control speed, but you also know the position. So you get the position almost for free. I mean, there are a few corner cases where you have to add some more capabilities, but it's all built into the system. Whereas with the system that is like that has fluids, you can't really control the fluids that precisely. So you need to put a control loop on the outside. So you'll have to put some additional measurement. Even if you wanted to find out the position of a hydraulic arm, you have to put something on the outside. And then because you don't have the high-speed control, you can't move very quickly. As you get to a stopping point, you need to start slowing down to make sure you haven't put in too much liquid, because backing it out is going to take a long time. So these core mechanical concepts in hydraulic systems and fluid-operated systems make it very challenging to build something that's precise, fast, and you can build on as far as an autonomous system goes.
Right. So I'm also thinking that there would be, I know the U.S. Air Force is, a large organization, consumer organization for technology like this. So for small and medium businesses, what's the lesson that you can share, or experience that you can share in starting with physical systems like this?
Yeah, so one of our commercial products is a lift gate. So lift gates, if you don't know what that is, it's typically on the back of trucks. trucks that are delivering to a store
Yeah.
typically have to load at a dock, but then deliver their products at the ground level. And so they need these lift gates to lower and lift merchandise. And hydraulic lift gates have a remarkably low reliability because they get abused, and over time, they don't respond well to temperature changes. So in the cold, stuff is sluggish. They end up eating a lot of batteries because the hydraulic systems are so inefficient. And so we built a lift gate that is twice as fast as a hydraulic system. And what it allows our customers to do, especially in food and beverage, is that they save 30 minutes in the day, because an operator typically spends an hour in food and beverage delivery every day going up and down the lift gate. So we make that twice as fast. We save them half an hour. That means an additional stop for the same truck. So they can make more money, or they can decide to cut back on overtime and save money. But all of those things add up. And so our systems make it possible for our customers to make more money and save money because the downtime is lower.
And is the ROI pretty straightforward for these customers? And how do you justify these automation investments for the scale of operation, the complexity of some of the associated infrastructure that they need to put in place to be able to leverage some of these technologies?
Yeah. So usually what happens is the infrastructure goes down, right? Because you need fewer parts to service these systems. For example, when we install one of our lift gates, it takes about 5 person-hours to install the system on a truck.
Yeah.
A hydraulic lift gate takes about 30 person-hours to install the system on the truck. Because not only do you have to install the lift gate, but you have to install the pump box, you have to connect all the hoses, and then you have to make sure the fluid's in the system. And it's actually the pulling and snaking the hoses through small openings that makes the whole installation very complicated. If you want to install our system, well, you put the lift gate on, you attach the battery box, you plug it in, it's ready to go. So installation costs come down. So that's one piece of the ROI. The second piece of the ROI is you don't have to stock hydraulic oil. And when you have hydraulic oil spills in your shop, you typically have to report it, and then you have to pay for remediation. But all of that stuff goes away. And then the second piece is on the maintenance side. A hydraulic lift gate typically costs roughly $4,000 a year to maintain. And we have practically no maintenance because we don't have any fluids, and the number of moving parts is very, very small, and the entire system is sealed and has no pumps, has no hoses, has no valves. The part count is a lot lower. The overall complexity is a lot lower, so they save on maintenance and downtime. And finally, as I mentioned, our systems move faster. So one additional stop for a food and beverage company could be anywhere between $300 to $1,200 more in revenue. So the ROI, especially when you include the additional revenue, is like 6 months.
And I would think that the operational efficiencies would possibly come once the machines have been plugged into your digital systems instead of analog systems. Is that a fair statement to make?
We can get productivities even without connecting them to something larger.
Yeah.
But to your point, our systems are digital from the get-go. There's a lot of data from the liftgate that's available. We can look at wear, we can look at battery life, we can look at the charge status, we can do a lot of diagnostics. Again, all of these things come for free because you already have the electronics driving the motors and you already have the sensors in there. So it's very easy to provide those sorts of things. So even troubleshooting these systems becomes easy. Remote monitoring of these systems becomes possible, because if you take a hydraulic system, typically they don't have any electronics and there's an on-off switch and a pump, right? And so when you move to something more sophisticated, you just get Industry 4.0 capability out of the box. Awesome.
I know you won U.S. Air Force contracts as a startup. I know that's not easy. What does that process really look like, and what should founders know about pursuing government work?
That's a great question. We started our process working with AFWorks, which is a innovative arm of the Air Force.
Yeah,
and we found them to be very supportive. And we started small. We wrote a white paper. They liked the white paper. They asked for a phase 2. We delivered well on the phase 2. And then they went to phase 3. So we've delivered $1.5 million worth of product already. And this is finished product to the Air Force. And then on the success of that, we started to land other contracts, right? And so my recommendation for founders would be, treat every opportunity as if you can turn it into a home run. because there are companies out there who are satisfied if they just get a lot of phase ones. That's not the goal. The goal is to start building and actually delivering products to the field. And if they start doing that, even at a small level, the confidence that the Air Force has in you or the Army has in you increases, and they're willing to be your partner in the long term.
Right. Okay. And in terms of the market for you, what are the industrial the segments that you go after? What are the verticals you go after?
Well, hydraulics is in a lot of spaces. So think certainly we talked about defense, but it's also in the marine sector. It's in transportation. It's in logistics, forestry, mining, construction. It's just all over the place. So what we've done is we've taken a step back and said, okay, let's focus on some key verticals where the customers can meet us where we are, where we don't have to invest a lot more in research and development. My charter at Rise is to commercialize and take the company from being primarily a research and engineering company to a product company. So I'm looking for customers that can meet us where we are and then use that to expand our capability. And the there are three sectors that are very interesting. The first one is the oil and gas space. So oil and gas production isn't going away. It also happens to be very energy inefficient. It's one of the dirtiest industries right now. And so we think we can clean it up, help our customers produce more and make more money. So we're looking at oil and gas very, very carefully. And one of the things about oil and gas that's interesting is most of these systems run round the clock. And so the gains that we provide, the 3 times the efficiency, the 3 times durability, the 3 times speed, all accumulate and compound over a day. And so they see the benefits more so than anything else. Their high utilization makes them great customers. So we're partnered with an OEM in that space, and we're looking at natural gas pumps, which are installed at every well. And we think that we can disrupt that market with something that is a lot more efficient, a lot more durable, a lot faster, which can make our customers more money, and then we can charge high margins for that. So that's one sector that's really interesting. The second sector that we're looking at is the marine sector. Captains of boats typically don't like hydraulic oil on their boats. They can slip on it. It's a safety hazard, hard to maintain. And on top of that, if they're out in the ocean, they don't want to leave behind an oil slick, right? And so there's a lot of interest from the marine sector to move away from anything that has hydraulic oil. So we find that space to be interesting. And then the third sector that we're pursuing is around food and agriculture. Hydraulic oil is hazardous, and so any food production company or any manufacturer that's selling into the agricultural space is interested in moving away from hazardous hydraulic oil, simply because it just creates all kinds of problems in the production process.
Right. So in that regard, from an agricultural perspective, I'm thinking here in Australia, that's big. Do you have any presence here on this side of the world, or are you looking at opportunities? What's the play for outside the United States in terms of what are you looking to build and gain access into?
Yeah, so we've started talking with companies in Europe, and we're definitely open to opportunities in Australia. What we want to find is a partner that can help with manufacturing, distribution, sales, so that we don't have to add to our headcount, but we can work through partnerships and create win-wins.
So Hiten, one question that comes up is that how do you fund yourself, and what are the opportunities for investors to invest into your company?
That's a great question. Thank you. Certainly, we're funded by contracts from the Pentagon. We are also funded by joint development partnerships that we have with OEMs. But we're doing something unusual. We've basically allowed retail investors to invest in our company. We've taken our last round, our last institutional round, and opened it up at almost the same terms to anyone that wants to join. Here in the United States, there's a program called regulation crowdfunding, which allows companies to crowdfund. And we partnered with a company called WeFunder. And so if folks are interested, they can go to our website and check it out at invest.riserobotics.com.
Awesome. I just also was curious to know what's that machine that you have in your backdrop?
That's a great question. A lot of folks ask about that. So that is a forklift test stand, and it holds one of our cylinders. So we use it to test both from a performance perspective, reliability, and so on, our cylinders. The specific cylinder that you see there is our first generation cylinders, one of our first generation cylinders. It's capable of lifting 50,000 pounds, roughly 22 tons. And it's very impressive when we have it in operation. But right now, the engineering team is still doing some development before we can do some more testing on it.
Excellent. Awesome. And so looking ahead, I mean, look, when AI came into mainstream consciousness and with all the discussions, and I even attended a play about the consequence of how AI becomes mainstream at home and whatnot. And then there was this whole question about job losses and what have you. And so is there a similar kind of concern raised by society in terms of jobs being lost because there's a lot more automation in heavy mechanized sectors like the ones you operate in?
Well, when it comes to, we can talk about things like ChatGPT versus automation and more automation sort of separately. When I've spoken to companies that are doing robotics in heavy machinery, what I've found is they're dealing with an aging workforce. Mm-hmm. And those jobs of operating machines outside, construction machines, heavy machines, typically have a certain amount of wear and tear on the body. Yep. And most of those workers end up retiring by the time they're 55. They're not in a situation where they can physically do the demands of the work. And that's where I think the automation comes in play, because it allows workers that were previously going to retire to extend their overall career, because they're able to use systems that have greater automation. For example, you and I can work from home, but a blue-collar worker working on a construction machine can't. As soon as we make teleoperation possible, well, they can work from home too if they have a sick kid, right? So there are these enablements that are happening. And given the demographic shift that's happening, I think there's going to be pressure everywhere, especially in blue-collar workers, to find ways to automate those systems and amplify humans even more. I don't see a replacement happening because, as I see it, if you want to double the effectiveness of AI, you have to wait a long, long time, because it gets harder and harder incrementally to add more performance. And that's where humans come in. I think there's always going to be a place for humans directing these systems, making decisions that they can't be trained on because they haven't encountered that situation before.
All right. And the final question from me would be, 2026, what are some of the trends that you're seeing in your industry this year, high level?
So electrification continues to be big, even though maybe the federal government support and priorities have shifted a little bit. The ports, for example, on both coasts are still electrifying. California intends to be zero emissions for its ports by 2030. The Port of Maryland recently got a grant from the federal government to go zero emissions. Mining is electrifying because it's getting, the mines are deeper and deeper these days, and it's getting harder and harder to send oxygen down to run gas-powered machines. And so with electrification comes batteries, and battery costs with hydraulic machines are very high. So we see this trend actually working in our favor, because as soon as you put a rise cylinder in place, your battery size goes down in half for the same runtime. So we see that electrification is going to be a big deal, and it's going to continue, and it's going to keep accelerating, and it's going to be a trend that's hugely in our favor.
So thank you, Hiten, for your time today. What's the best way for our audience to reach out to you?
Oh, the easiest thing to do is to go to our website, riserobotics.com, and there's a form there. They can drop me a note, or they can reach out on LinkedIn.
Fantastic. That's all we have time for on the Complete AI Guide podcast. Thank you for joining us today, and we hope you can join us on our next episode. Until then, don't forget to like, follow, share, and subscribe. And also check out our upcoming masterclass at www.georgeabmatthew.com/masterclass. Goodbye for now.